So today what I want to look at is let's say we're given a certain amount of data and we want to make a model of it. All right, we did this once. What were we working with? Oh, with the tide coming in. Okay, we saw that model for the tide, and we were estimating based on how deep the water was at its deepest, that was the max, and then the shallowest was the min. And remember, we figured out what A, B, C, and D were for the model. I want to do a little bit more practice with that today, and I also want to talk about bearings, which they're kind of a different way of measuring angles, but it's used in things like navigation and surveying, orienteering. We'll talk about that here in a moment. But let's start with the model itself. And one thing I wanted to do a model with was, let's say we want to make a model for the phases of the moon. We can tell what phase the moon is based on what day of the year it is, okay? And the nice thing is for us, it's January, so figuring out what day of the year it is pretty easy. Okay, if this were August, we'd have to do some thinking, 31 and 30 and 28, and add them all up to figure out what actual day of the year it was. But I got this shot of the chart of the phases of the moon for this month, okay, and this is current. So today, it's getting towards full. It's a waxing gibbous, if you're into astronomy. But you'll notice here, we had a new moon back here on the 10th, all right? Pen good. There we go. All right, back here on the 10th, we had a new moon, and on the 24th, you'll see, it's kind of hard to see, but this one, there's a little bit of shading on the 23rd, and then 25, it's just starting to wane. So the 24th is when we'll have a full moon, okay? So what we're going to do is create a model for this so that we could punch in any day of the year and figure out what phase the moon is going to be at, all right? Now, one important thing, though, is to define our variables, okay? Because obviously I can't, let y equal the phase of the moon, because how do you plot new or full or crescent or whatever? Those are categories, they're not numbers. How could I, though, define y to represent it?
The percentage of the moon that is lit up compared to percentage that's not.
Yeah, you could. What percent of the moon is lit up? So if I let y be the percent of the moon that is lit, okay, then my new moon, what's the y coordinate going to be? 0. All right? None of the moon is lit up, theoretically. Okay? What are we going to let x be, though?
10.
It's going to be time, but how are we going to define our time? The day of the year, okay? The day of the year. All right? So it's the day of the year. So this point right here would be the point 10, 0. Okay? Here at the full moon, I would have the point, it's on the 24th, this coming Sunday is the full moon. And that, what we could do, it's really up to you what you prefer. You can either think of the percent as an actual percent we're converting to a decimal, so it would just be 1 for 100%. Or you could make our graph go from 0 to 100. And that might be easier so we don't have to mess with decimals. Okay? So we're going to call this point here 24, 100, because it's a full moon. 100% of the moon is lit up. Okay? So now, I hope you notice here there's a little bit of flexibility. There's some room for you to do some interpreting. You can define the variables. You know, like we said here with y is going from 0 to 100. If you wanted to make it from 0 to 1, you're welcome to, but you have a little bit of flexibility, and that's why it's important anytime you're making a model to make sure you define these variables clearly and define the points that you're given clearly. Okay? So let's graph what we have so far. Okay? So far, here's 10, and we are at 0. And then by the time we get over here to 24, we're going to be up at 100. Okay, so 24, 100. And we know that this is, you know, a sine or a cosine curve, so it's going to look like this. All right? Now, question, what do you want to use? Do you want to use sine or do you want to use cosine?
Cosine.
There's no wrong answer here.
Yeah,
You want to use
cosine.
cosine? All right, let's use cosine. All right, now those of you who said cosine, why do you pick cosine?
The ending.
What?
The ending.
Because it ends up here?
Yeah.
So you want to make, since that's at the top, is that where you want to kind of make our shift? Is that what you were thinking? Because that's going to start a new period right here, right?
Yeah.
Okay. So yeah, here we can very easily identify the start of a brand new period. So yeah, let's use cosine. We're going to make y equal a cosine of bx minus c plus d. Now, because of what Hunter just said, he's seeing this as a brand new period, so we could look at that as the starting point or as where our graph is shifted over to. Okay? Now the fact of the matter is, depending on how you see this, you could have it shifted to a lot of different spots. Okay? Because it's periodic. It's going to repeat. But since we have that one there, let's go ahead and make that our horizontal shift. So h is 24. Okay? Now h is not in here, but what does h equal? It's, you remember what h is? C over b. Okay? C over b. So since we know that that equals 24, if we can figure out one of those two, with some of the other features we see here, then we can figure out the other one. Okay? So now, looking at what we have, what features can we get for our equation here? What do you see?
The amplitude is 100. Oh, no, never mind, 50.
Very good. The amplitude is 50.
Yeah.
All right? The amplitude is 100 minus 0, the max minus the min divided by 2. So it's 50. All right, so that's good. We know our amplitude. What else can we figure out?
Period.
Okay. How are we going to figure out our period?
2 pi over b equals 24.
Okay, 2 pi over b. You're saying the period is 24. Now, how are you getting 24?
Because from 0 to 24 is a full period. Or no, not from 0 to 24. 24 on is like one full period. So you get it's the beginning and then I don't know if this is making sense.
Okay. We do have to kind of look at this to figure out what a full period would be. How can we do that, Hunter?
I think it's 28.
You think it's 28? Why do you think it's 28?
Yeah, it's half of period is 14.
Okay. Notice here's the min and here's the max, right? So half of the period
Yeah.
is 14. Okay?
Yeah.
So our period should be 28. And that's a really easy thing to do. You see the 24, you automatically jump to thinking that. But look for that max and min point. That's kind of the easiest way to identify what half of your period was. Then you obviously then double it, so we have the period to be 28. Okay? Now this is significant because now we can figure out what B is. And like we said earlier, once we know B, we can get C. And we're almost there. The last thing is just going to be D. Alright, so given this, what does B equal? Oh, you guys can do this? What's B equal?
Pi over 14.
Pi over 14, okay? Pi over 14. Alright? So now, we can bring that back up here. I know C over pi over 14 is going to equal 24. So what does C equal?
Times 24 pi. Right?
24
almost.
14.
24 pi over 14.
Oh, I see. Yeah.
Okay? And then that will reduce down to 12 pi over 7, right? So 12 pi over 7. Okay, so check this out. We have almost our entire answer now. We have y equal to a, which is 50, cosine of bx, so pi x over 14 minus c. C is 12 pi over 7. All we need now is the plus d.
Can you just plug in 2 points?
You could, but it's actually easier than that. How do we find d?
D is fixed.
D's what? D's our vertical shift, right? So how do we find d?
Oh,
What?
Is it just the?
That's a standard
It's not 100.
It's 50.
What?
Is it just 0 because it didn't translate?
Well, it did translate. Remember, cosine normally goes from positive 1 to negative 1. And if the amplitude were 50, it would go up to 50 and down to negative 50. So, yeah, it's shifted 50 units up.
Yeah.
Okay? And that's where you can use your amplitude as well here, guys. Okay? It's going to go right through the middle. If the amplitude is 50, you can either go up from the minimum or you can go down 50 from the maximum. Either way, 0 plus 50 or 100 minus 50, you're going to end up with D equaling 50. All right? So there's the final piece of our model. Okay? And now, if we wanted to figure out, you know, what's going to be the phase of the moon, say, on Valentine's Day? Okay? Are we going to have a full moon for Valentine's Day? All right, let's see here. Valentine's Day is February 14th, right? February 14th. So what day of the year is that? X equals... How many days are in January?
31 plus 40.
31, so plus 14. 45. The 45th day. Okay, so let's look at the graph here. Let's look at the graph here. Okay. Okay. You guys can try graphing this on your own as well. You got to get used to dealing with the windows, okay?
Oh yeah.
All right, so here we go. Oh, what's first thing that we want to do? Make sure we're in radians, right? Okay. I'm in radians. Make sure you're in radians because you've been doing some application problems in degrees. That'll mess you up. Okay. So here we have 50 cosine pi x. Pi x over 14 minus 12 pi over 7. Watch your parentheses. Make sure you have parentheses around the whole pi x over 14 minus 12 pi over 7. And then plus 50. Okay? What would be good to set our window at? What? We could do x going from 0 to, we got to go at least to where?
Maybe like 110.
Okay, we could. We at least have to go to 45, right? Because we want the 45th day. So let's maybe make it go to 50. And then the y we're going to want to go from 0 to like 110 or something so we can see that top. That'll be nice. All right? And we can see the graph here. Now, one thing the graph shows us too, that just plugging the number into the equation won't show us, is are we getting closer to a full moon or is it going away from a full moon? Okay, so let's see. If I hit trace, by the way, here's the little feature that's really nice on your calculator. If you want to evaluate for x equals 45, hit trace and just type in 45 and hit enter. Okay, so hit the trace button, type in 45 and hit enter. And y equals 50. So it's a half moon. This year it'll be about a half moon. Okay. It'll be a half moon on Valentine's Day. Will it be getting fuller or will it be going towards a new moon at this point? It'll be getting fuller, right? Because look, this right here, do this. This right here is increasing, right? So we're approaching a full moon. Okay, so we would call that a waxing half moon. We wax to full and we wane to new. All right, so there you have one use of our model, okay? And I'm going to just do that. Yeah, there we go. Okay, so here's our model. And again, you can, the nice thing about this model now is you can type in any value for x and you can figure out what phase of the moon it's going to be on. Okay, using those percentages. All right, questions? All right, kind of cool stuff. And you can do this with anything that changes periodically like this. You know, it changes on a consistent rate. Again, this is how they're able to say sunrise is going to be at this time today. Because they have a model like this. Okay? And they've modeled it in the thing is every different city basically has to have a different model. Okay? Here, we're closer to the equator than, say, back up north in Cleveland. So it doesn't fluctuate quite as much throughout the year. You still have longer nights in the winter and longer days in the summer. But up in Cleveland, this time of year, it's getting dark, you know, at like close to 5 o'clock in the evening. It gets dark really late. But in the summer, it'll be light out till like 9:30 at night. So here it doesn't last that long. So it fluctuates different. So every different location would have to have a different model for their location. So kind of an interesting study here. The other thing I wanted to address here was problems involving bearings. Okay, we'll just address this a little bit because really the problems aren't any harder. It's just the way the angles are measured. So I wanted to point out the way these angles are measured. You'll see here it says south 35 degrees east, north 80 degrees west, north 45 degrees east. What we're talking about here is the first letter tells you where you're going to start measuring from. And then obviously this is the angle. And the second letter tells you which direction you're going to measure from that. Okay? So obviously you can see it drawn here, but if I were doing this, I would say, okay, here's my starting point. Here's due south. Okay? And you have north, south, east, west. So east is to the right. I'm going to measure 35 degrees, but I could measure 35 degrees this way or this way. This is telling me to do it towards the east. Okay? Whoever that is, turn it off, please. Oh, is it? Oh, okay. Sorry. All right, so there you have a south 35 degrees east. That's really the key when you're drawing a picture for, say, a situation like this. Okay, here we have this ship, and it's at port. Okay, and it leaves port and heads. Whoops. And heads due west for 2 hours at 20 knots. So how far has it gone? Knots are nautical miles per hour, so it's gone 40 miles. And when it says due west, that means at a perfect right angle from north. Okay? So there's west, that's 40 miles. Okay? Then it says that it changed course. So right here, we decide to change course, and when we're drawing this, let me show you something that's helpful. Draw yourself a little north, south, east, west anytime you're going to change course. Because now we want north 54 degrees west. So here's north. I'm going to measure a 54 degree angle, but I could go this way or this way. West is to the left of north, so I'm drawing a 54 degree angle this way. Okay? Now notice that's the angle between north and the path that we went. And I kept going that way from 2 o'clock until 3 o'clock, so that one was only 20 miles. But notice now what you can do. What is this angle right here? Yeah, 144, because this is a right angle, so that's 144 degrees. And now they ask for the bearing and distance from port to where they ended up. They're looking for that distance right here, and then there's also, they're going to be looking for this angle, because that's your bearing. It's going to be north something degrees west. Okay? So let's say that this was some kind of a treasure ship, or it had some kind of valuable cargo and it was sinking, and the captain bailed out and was able to survive. Okay? He had his logbook and was logging where he was traveling. He can then figure out where he needs to search. Okay? If they want to retrieve what was on the ship. Okay? So they can figure out, okay, I was going this direction for this distance. We should start looking here. Okay? And then here's this isn't related to trig, but there's actually a mathematical model. You know, the best way, if you know in general where something is, you know what the best way is to look for it if you're by yourself? You know?
Yeah.
What?
Just create the. Yeah.
It's created.
Yeah. Try.
Okay. If you know it's somewhere around here, it's actually, if you start spiraling out, mathematically that's the best way to find something fast. So kind of a cool
Do that next time I lose my phone somewhere.
yeah.
Spiral around.
Yeah.